The formula to find the area of a triangle is very similar to the formula for area of a parallelogram, except there's one important difference. So the area of a triangle is 1/2 times the base times the height, which can also be thought of as the base times the height divided by 2. So it's very, 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 very similar to parallelogram, except we're dividing it by 2. We're multiplying the base and the height, and either multiplying it by 1/2 or dividing it by 2. These are the same thing. So whichever way you prefer is great. And just like the base and the height had to be perpendicular in a parallelogram, the base and the height have to be perpendicular in a triangle. So here's an example of a right triangle where it's really easy to identify what's your base and what's your height. Sometimes your height is inside the triangle, so this is like an altitude. We learned this a long time ago. This is also called an altitude. So the height of your triangle in the formula is the same thing as the altitude. It makes a right angle with the side, goes through the vertex. Sometimes though, if you have an obtuse triangle, like this right here is your base, and then this is the height. It's technically imaginary. That's why it's dotted, but sometimes the height is sort of like floating outside of the triangle, or if you thought like it kind of would look like this if you like scooted it in a little bit. But always look for the height forming a right angle with your base. So I want you to know this dotted part right here is not a part of the base. This is imaginary. This is like an imaginary little triangle there to help you visualize. This dotted part does not exist. So it's not like you're going to add these two pieces together. Like the base is just this side of the triangle.